All right, Joel here. We're going to do part two. We're going to try. I've been having various technical difficulties. And so we're going to try and implement adding, which sounds easy, but which is not easy. So let's make a new branch for this. Check out part 02. That's good. And, yeah. Okay, good. So, all these stupid caches. Right. So we want to do, I'm going to add two tensors. T1 is a tensor, T2 is a tensor, and that will return a tensor. And so, just like when we did tensor sum, we want to return a tensor with some data and with a requires grad and with a depends on. So again, we're going to lean on NumPy to do all the heavy lifting. T1.data plus T2.data. So we pull out the tensors inside T1 and T2 and we add them together. So that's easy enough. With the requires grad, what we said is that we want something to require a gradient if anything that it depends on requires a gradient. So that means that if I have a new tensor which is T1 plus T2, it will require a gradient if either of them does. So T1 dot requires grad or T2 dot requires grad. So that's easy enough. And then depends on is kind of the interesting part. So let's just say depends on, which is a list of dependency, and that's this. And now we're going to have some duplicated code, and I hate duplicated code, but we're going to have it anyway. So we'll say, you know what, if T1 dot requires grad, then we have to add a dependency on T1. And so depends on dot append dependency of, and dependency takes a tensor, and let's say grad function 1. And so now we need to define what that grad function 1 is. So what is grad function 1? It takes some gradient with respect to this sum T1 plus T2, and that will be a NumPy array and outputs NumPy array. And so what's the idea here? The idea is that similar to what I had with using the sum. So idea, if I do 1, 2, 3, if that's one tensor and I have another one, 4, 5, 6, which is another tensor, and so I get this 5, 7, 9, or whatever. And let's say I have some gradient that says when I increase this 5 or whatever by a little bit, I get some change in my ultimate error. Then, increasing the 4 by a little bit will increase the 5 by a little bit. Increasing the 1 by a little bit will also increase the 5 by a little bit. So basically what I'm adding is I'm saying, if I do 4 plus E here, then I get 5 plus E here, right? And so what that means is that because every change here is reflected exactly there, it has to get the same gradient as that. And similarly, if I do 1 plus E there, same thing. So what that says is that I just need to, and here we're doing grad function 1, so we're only worrying about this guy. And so we want to take the gradient as is. And so we'll just return the gradient. So whatever the gradient is with respect to these guys, if these guys enter additively, then it's the same. So that's easy enough. And I'll just do if T2 dot requires grad, and I'll do def grad function 2 grad np dot end array, and I'll also return grad. And then I'll do depends on dependency T2 grad function 2. So this looks good, and it's wrong, but it's wrong for a subtle reason. So let's write a test where it's right, and then we'll write a test where it doesn't work as well, and then figure out how to fix it. So let's do test tensor add.py, and let's just copy a bunch of this stuff because it's boilerplate. Okay. So let's do test simple add self, and T1 is a tensor of, and let's just use that example, requires grad equals true, and similarly I'll say T2 is a tensor of 4, 5, 6, also requires grad equals true, and if I wanted to be like a really serious unit tester, I would check when some of them don't require grad. I'm not that serious unit tester right now, and so I'll say T3 equals, and I'll import that add T3 equals add T1 and T2, and later on we will add the methods to the tensors themselves, so I can write T1 plus T2, but I'm not doing that yet, and we'll fix that later. Should I do that now? No, I'm not going to do it now. And now the problem, so that's fine, and now I can say T3 dot backwards, and now because it's not it's not a zero tensor, I have to actually say what I'm doing backwards, and so I'll just say I want to go backwards 1, 1, 1, and then I want to assert that T1.grad equal dot data dot toList, that one equals 1. Actually, you know what? To make this more interesting, let's say that this is 5, 7, 9. Actually, let's not do that one. Minus 1, minus 2, minus 3. And so we should make sure that it's just getting passed back as is, which is what we said. And then same. And now let's run PyTest and see what happens. And that passes. Okay, great. So that's good. So why did I say this was wrong? This is wrong because NumPy does what's called broadcasting. And so what does broadcasting mean? Broadcasting means a couple things. What is broadcasting? A couple of things. So if I do T1 plus T2, and T1.shape equals T2.shape, it's obvious what to do. That's fine. But I'm also allowed to add ones to the beginning of either shape. So what does that mean? So, let's say I have a 10 by 5 matrix. So T1 is 10 by 5 matrix, 10 rows, 5 columns. And let's say T2 dot shape is 5. So T2 is just a vector of length 5. It turns out we're allowed to do T1 plus T2. And what happens is if I do T1 plus T2, T2 gets viewed as 1, 5. So I can just add ones to the beginning. And so what does that mean? If I say T2 is basically 1, 2, 3, 4, 5, then I can view T2 as 1, 2, 3, 4, 5. So instead of viewing it as this one-dimensional rank 1 tensor with 5 elements, I can view it as a matrix with 1 row where that row is that thing. And I could do it again and again. I can just keep adding dimensions by putting it on the inside. So I'm allowed to add ones at the beginning of either one until they have the same number of dimensions. Okay. the second thing I can do is that if, one tensor has a 1 in some dimension, I can expand it. So, here I have T2 as this 1, 5 thing, which is, again, 1, 2, 3, 4, 5, but, and T1 as, some kind of 10, 5. So T1 has 10 rows, each of length 5. T1 now has 1 row of length 5. And so what I can do, and this is why it's called broadcasting, is that I can just add that 1 row of T2 to every element of T1, right? To every row of T1. And that's, in fact, exactly what happens. So if I do, import numpy as np, and x equals np dot random dot randin, let's just say 3 rows and 2 columns. So, and now if I say y equals np dot array, minus 10 plus 10, if I do x dot shape is 3 by 2, y dot shape is just 2 comma, and so what I can do is I can say x plus y, and it will treat y as a matrix where each row looks like minus 10, 10. And so it'll be like minus 10, 10, minus 10, 10, minus 10, 10. So it'll add minus 10 to each of these, and it'll add 10 to each of these. So if I do x plus y, then you can see it added minus 10 to the first column and plus 10 to the second column. And so that's how broadcasting works. And so broadcasting is going to cause us a fair amount of grief for the following reason. Think about this example where I have x, which is this 3 by 2 matrix, and I have y, which is just this 2-element vector. And now I want to take their sum. Now, where does this 10 go? It goes here, but it also goes here, and it also goes here. So basically, to get the gradient with respect to, say, minus 10, I have to add up all the gradients that it goes into. So that's 3 different places. And similarly with respect to the 10, I have to get 3 different places. And so that's a pain, and we're going to write a test that fails and see why that's tricky. So that's a long-winded way of saying, T1 equals tensor, and let me do it like this. 1, 2, 3, 4, 5, 6 requires grad equals 2. That doesn't make sense. Requires grad equals true. And then T2 is a tensor, and let's just let this one be 7, 8, 9. And that requires grad equals true. So now, this is shape 2, 3, and this is shape 3, comma. So let's let T3 equals add T1, T2. Okay, and so this will also be shape 2, 3. And let's do T3 dot backwards. And I'll just make this really easy and say 1, 1, 1. 1, 1, 1. So just assume it's 1 in every one of those, 6 output spots. So T1.grad.data to list should equal, and this one is easy because, like I said, each should go in equally. And just, if I increase the 2 by a little bit, I have increased the corresponding thing by a little bit, so its gradient just goes back to the 2. So that's easy enough. T2 is the interesting one. So T2 is these 3 numbers, but like I said, each of these goes into the final result twice, right? Because the 789 gets added to the 1, 2, 3. The 789 also gets added to the 4, 5, 6. So what that means is that this 1 corresponding to the 1 that goes into the gradient for 7, but this 1 corresponding to the 4, that also goes into the gradient for 7. And so that means that this should really be 2, 2, 2. And the way we've written it, that's not going to be the case. So if I run PyTest, that should fail, although it failed for the wrong reason. That's invalid syntax because I forgot to close my brace. Okay, so value error, non-broadcastable output operand with shape 3, doesn't match the broadcast shape 2, 3. Okay, so that's a complicated way or a non-clear way of saying what we just said, which is that we didn't handle the broadcasting properly. So handle broadcasting properly. Okay. So what do we need to do? So, the issue is we had, so there's two things going on. One is we may have added 1s to the beginning of the shape. And the second is we may have broadcast 1s to the, at any point in the shape. So let's say numdims added equals grad dot ndim. So that's the number of dimensions. So if I had like a 2 by 3, or, a 5 by 7 matrix, that's 2. If I had 5 by 7 by 9, that'd be 3, and so on. So I look at the gradient number of dims minus t1.data.ndims. Okay? So if ndims added is positive, that means that I implicitly added some 1s at the beginning. So what I want to do is I just want to go through and sum those out. So I'll say for whatever in range in range ndims added, and I'll say grad equals grad dot sum axis equals 0. So let's say I added 1, 1 to the beginning. That means ndims added will be 1. So I'm just going to sum the gradient along that axis. So that's fine. And now what I want to do is, so that's good. And I think that will even fix this case. So let's try this. Ndims added equals this minus t2. So I think that handles, I think this case. Ufunc add output type code L according to the rule same kind. And I think that is saying, not sure what that's saying actually. That's really interesting. But let's say this is tensor 1.0. But that probably means something bad. Ufunc add output cannot be coerced provided output parameter type code L according to the casting rule same kind. Okay, well that's not good. So let's figure that out. 3 failed. It's interesting. Tensor add failed. Interestingly, the tensor sum failed as well. So why did... that's really interesting because that one passed. So let me skip this one and see what happens. So I'll just mark that one to skip and try doing it again. cannot cast ufunc add output from dtype float64 to dtype ent64. Okay, so that might be a problem in 0grad, let's say. Dtype equals np.float64. Let's see if that works. Nope. Init got an unexpected keyword dtype because that should have been inside the zeros like. So dtype is telling NumPy what kind of data type do I want. Okay, so now that passes. This is interesting. Debugging things is always an adventure. So now let's try this and see if it works or if it's broken in some other way. Still failed. Ufunc add output type code 0 cannot be coerced to provided output type code D. And self.grad data plus equals grad data. So let's do some fancy print debugging. Print grad.data, grad.data, print self.grad.data, self.grad.data. You can see what kind of debugger I am. Let's do -v so it'll print stuff more verbose. Grad data, grad data, grad data none. That's a real problem. Why is grad data? So it looks like those were fine. Why would grad data be none? Assert grad.data, grad.data is none, and then let's just figure out who this is. Okay, assert grad.data is not none. Interesting. So grad data was not none, so that wasn't the problem. So let me put those print statements back. Grad.data, data, print self.grad.data, self.grad.data. So how is grad data.none if I have that assert there? It's real interesting. The only thing is that it's angry about these decimal points, possibly. Let's see if that does anything. Nope. Ufunc add output cannot be coerced to provided output to the casting rule. Okay. Time to go ask Mr. Google. Ufunc cannot be cast with rule same kind. That doesn't look like it's that helpful. Let's look at this one. Using the casting arguments. I don't want to do casting though. Type code D. I want to find out what those mean. This looks promising. Although I did see something about in place. I wonder if it could be as simple as saying self.grad data equals self.grad data plus grad data. I wonder if that would do it. Sometimes in-place operations are tricky. Unsupported operand type for plus float and none type. Okay, so that's good. Print grad. Okay, well that's not good. So why is that? That is because return tensor data equals T1 data plus T2 data. Oh, because I forgot to put a return grad there. That's a lot of trouble for. Okay, we're getting closer. To list equals that. Okay, good. They all pass. So that's fantastic. But now, here's another. So that's one kind of broadcasting, adding once to the beginning. So that's fantastic. The other thing I can do is T1 equals tensor. Well, so this is an easy way to do it, is basically let's add this extra dimension here. So now that's 2, 3, and that's 1, 3. So the same thing is happening here, but now we don't need to sum out that extra dimension. We want to keep it, but we still so now it should be the case that we get all these 2s. We have an extra dimension there, but we don't want to sum the dimensions away. But we still need to aggregate the fact that this 3 vector or this row goes into that row and that row. So we need to add them together. And now if I run PyTest on this, it probably will fail with some kind of error. And it's basically doing the wrong thing. So we need to go back and do one more thing, which is, let me change this comment and say sum out added dims. And now we need to sum across broadcasted but non-added dims. So what do I mean? What I mean is, if I had something that's 2 by 3 plus something that's 1 by 3, then the output is 2 by 3, and so the grad will also be 2 by 3. But I need to get back to something 1 by 3, and I get there by summing across each of those dimensions, but not summing them out. So previously when I summed, I got 1 dimension less. Now I want to sum, but I want to keep that dimension there. So what do I want to do? I want to say for I dim in enumerate T1.shape, say. Okay, so if it's 2 by 3, I'll get 0 with 2 and then 1 by 3. And so if the dim equals 1, then that's a broadcasted, it's potentially broadcasted. Maybe it's not if the other one is 1, but if the other one's 1, it's not going to matter. So what I want to do is I want to say grad equals grad.sum, axis equals I, but now I want to say keep dems equals true. And then I need to do the same thing down here, sum out added dims, and this makes our things slightly inefficient and makes them run a little bit slowly. So let's do t2.shape, and that should be fine. And I need to do that before I return the grad, otherwise it wouldn't make much sense. So that looks good. And so now if I run PyTest, I think it's all going to pass. Good. So between those tests, I feel like that's pretty good. So yeah, that was more difficult than it should have been. But every step of this is more difficult than it should be, and that's okay. We like doing difficult things. So I think I'm going to call that a stopping point. Next time I'll do multiplication, and it's really, it should be easy because it's going to have all the exact same problems that we had here, because broadcasting for multiplication works exactly the same way it works for addition. And so I can basically almost copy the code verbatim. So let me get branch, part 02, so get status, get add autograd tensor.py, get add tests, get status, get commit m part 02. Oh, and I can git push origin part 02. I'm sticking all this up on GitHub. And good. So I think that's it for now because I'm running out of steam. But I will work on this some more later. So thanks for watching.